Welcome back, everyone. Today, we're going to be taking a deep dive into the world of large language models, or LLMs for short. Those AI systems that can do all sorts of crazy things with language, writing poems, translating languages, even answering your questions in like a split second.
Yeah, it's pretty wild what they can do.
It is. Now, you specifically sent over a research paper with an interesting title.
Chain of thought prompting elicits reasoning in large language models.
That's it.
Yeah,
Now, I gotta admit, that sounds a little intimidating, maybe even a bit jargony, but it's really about unlocking a hidden talent in these massive models, right?
exactly. It's about the ability to reason, which is something LLMs have traditionally struggled with.
So before we get into the nitty-gritty of the research, let's just, for our listeners who might be new to this, can you just read us a quick, ELI 5, explain it like I'm 5, what are LLMs?
Sure, so imagine a giant brain that's been fed a massive amount of text data. Like think the entire internet, books, articles, code, everything.
Wow, that's a lot of information.
Right. And LLMs learn from all this data to understand and generate human-like text.
Yeah.
They can write different kinds of creative content, like poems, codes, scripts, musical pieces, email, letters, etc. They can answer your questions in an informative way, even if they are open-ended, challenging, or strange. And they can be used to translate languages, write different kinds of creative content, and answer your questions in an informative way.
So they're already doing all sorts of amazing things, but as you said, they haven't been so great at reasoning.
Right. They can, write a beautiful sonnet, but if you ask them to solve a math word problem, they might get stumped. It's like they're missing a key piece of the puzzle.
Okay, so that's where this research paper comes in. It's saying they found a way to make LLMs better at those, tougher thinking tasks.
Yeah. That's the gist of it. And the technique they used is called, well, we've already said it, chain of thought prompting.
Chain of thought prompting. Okay, so break that down for us. What exactly does that mean?
So think about how you solve a difficult problem. You don't usually just jump to the answer, do you?
No, definitely not.
You kind of break it down into smaller steps. You think it through logically. And that's exactly what chain of thought prompting does for LLMs. Instead of just giving the LLM a question, we give it a few examples of how to think through a similar problem step by step using natural language.
So it's like we're showing them how to think like a human.
Exactly. We're kind of guiding them through the reasoning process.
And this actually works.
Yeah, surprisingly well, actually. The researchers found that this simple technique dramatically improves the reasoning abilities of LLMs,
Hmm.
especially those really massive models with a ton of processing power.
Wow. So it's like we're switching on a light bulb inside their artificial brains.
I like that analogy. It's a good one.
Oh, I try. So what kinds of problems were they using to test this out? I mean, how do you even measure an LLM's ability to reason?
That's a good question. They used a variety of tasks that require different types of reasoning, like math word problems, we've already mentioned those, but also things like common sense reasoning, like figuring out why someone might do something or where they might go.
So like everyday scenarios that we humans take for granted.
Exactly. Things that seem obvious to us, but are actually quite complex for a machine to grasp.
I see. And they also tested something called symbolic reasoning, right?
Yeah, that's another one. It's kind of like solving a logic puzzle where shapes and symbols have different meanings.
Ooh, that sounds tricky. So how does chain of thought prompting help with that?
Okay, imagine a logic puzzle where a triangle means move forward and a square means turn right.
Yeah.
Normally, an LLM might struggle to understand those symbols and solve the puzzle. But with chain of thought prompting, we can give it examples. We can break down how to interpret each symbol and make the right moves.
So like giving them a secret decoder ring.
Exactly. And once they understand the rules of the game, they can apply that knowledge to solve new puzzles they've never seen before.
So they're actually learning to think for themselves? I mean, in a way.
Yeah, I mean, it's still early days, but the results are definitely promising.
This is already blowing my mind, and I can only imagine the potential applications of this. But before we get, carried away with all the possibilities, let's just focus on the research itself. What were some of the key findings? What really jumped out at you?
Well, one of the most striking findings was, it's illustrated in figure 1 of the paper, actually. They gave an LLM a math problem, and it got it wrong.
Okay.
But then they showed it a chain of thought example for a similar problem, and boom, the LLM was able to solve the original problem correctly.
Wow, that's impressive. So can you walk us through that example? I'd love to see how it plays out step by step.
Sure. So the problem they used was from a a data set specifically designed to test math reasoning. And it was a word problem about um, someone buying cans of tennis balls, and they needed to figure out the total number of balls.
Mm.
And like I said, initially, the LLM just couldn't get it right.
Okay, so then what happened? What did they change?
Well, they gave it a different prompt, one that included a chain of thought example.
Uh-huh, so that was the key. And what was the example they used?
It was a similar word problem, but this one was about apples in a cafeteria. And the important thing is, the prompt didn't just give the problem and the answer. It also showed the step-by-step reasoning process, written out in simple language.
So they showed the LLM how to break down the Apple problem into smaller steps.
Yeah, exactly. And the amazing thing is, with that additional guidance, the LLM was then able to solve the tennis ball problem correctly. It even wrote out its own chain of thought, like showing how it arrived at the answer.
No way. That's amazing. It really highlights how this technique is like giving these LLMs the tools they need to unlock their true potential. Okay, so we've talked about math word problems. What other kinds of problems did they test this on? You mentioned common sense reasoning earlier.
Yeah, so they gave the LLM a question like, Sammy wanted to go to where the people were. Where might he go?
Hmm.
And then they gave it a few options to choose from, like a racetrack, populated areas, a desert, an apartment, and a roadblock.
Okay, so I'm guessing the LLM was supposed to figure out that Sammy probably wants to go to a place with a lot of people.
Right.
So populated areas, but without chain of thought prompting, would it even be able to make that connection?
That's the thing. Without that extra guidance, LLMs often struggle with these kinds of common sense reasoning tasks.
Because they're so reliant on like patterns in the data.
Yeah, they might get distracted by irrelevant details or just miss the underlying logic of the situation.
But with chain of thought prompting, they're able to think things through more like a human would.
Exactly. So in this case, the LLM, after seeing a chain of thought example, was able to reason, populated areas. That must be the answer because that's the only option that consistently has a lot of people.
That's incredible. It really does feel like we're witnessing a breakthrough in how we teach AI to think.
Yeah, it's pretty exciting.
Okay, so we've seen some pretty impressive examples, but I'm also curious about like the limits of this technique. Are there any types of reasoning that are still beyond an LLM's grasp, even with chain of thought prompting?
Yeah, that's a great question. And it's important to remember that even with this breakthrough, LLMs aren't perfect. They can still make mistakes. Their reasoning can sometimes be flawed, leading to, wrong answers.
So it's not like a magic bullet.
No, not at all. And it's also worth noting that this technique seems to work best for those very large models, which, as we mentioned before, are super expensive to run.
Right, so there are definitely still some practical challenges to overcome.
Hmm.
But it's just the beginning, right? I mean, imagine the possibilities as research continues.
Oh yeah, the possibilities are endless. This is just scratching the surface of what we can do with AI and reasoning.
Yep.
So, yeah, we talked a lot about the potential and, even some of the limitations of chain of thought prompting in LLMs. But I think it would be really helpful to dive into some concrete examples for the paper just to kind of illustrate how it actually works in practice.
Yeah, I think that would be great. I'm like really curious to see how these LLMs, perform when they're given these chain of thought prompts.
All right. Well, let's revisit that math problem we talked about earlier. The one where the LLM initially got it wrong, but then after seeing the chain of thought example, it was able to solve it correctly.
Right, the tennis ball problem.
Exactly.
Yeah.
So initially, the LLM just gave the wrong answer. It's like it got lost in the details of the problem and couldn't quite piece together the necessary steps to solve it.
Yeah, it's not like a straightforward calculation, right? There's like multiple steps involved.
Right, exactly.
Yeah.
So what the researchers did was they provided the LLM with a different prompt, one that included a chain of thought example. And this example, it was a similar type of word problem, but it was about apples in a cafeteria.
Ah, okay.
And the key thing here is that the prompt, it didn't just give the problem and the answer. It also showed the step-by-step reasoning process, written out in clear, simple language.
So they basically showed the LLM how to think through the problem like step by step.
Exactly, yeah. And the amazing thing is that the LLM was then able to take that reasoning process that it learned from the apple problem and apply it to the tennis ball problem.
Wow, that's incredible. So it's not just like memorizing the steps, it's actually learning a way of thinking.
Right. And that's what's so powerful about this chain of thought prompting technique. It's not about, teaching the LLM specific facts or formulas, but about teaching it a way of thinking, a method for breaking down these complex problems into smaller, more manageable steps.
Okay, so we've seen how it works with math problems. What about those common sense reasoning tasks that you mentioned earlier? Can you give us an example of that?
Sure. So, for example, the researchers, they asked an LLM this question. Sammy wanted to go to where the people were. Where might he go?
Hmm. Okay.
And then they provided a few options. A racetrack, populated areas,
Hmm.
a desert, an apartment, and a roadblock.
Okay, so the obvious answer is, populated areas, right?
Yeah.
But would the LLM be able to figure that out without any prompting?
So without any prompting, LLMs, they often struggle with these types of common sense reasoning tasks. They might, get distracted by irrelevant details, or they might miss the underlying logic of the situation. But when they're given a chain of thought example,
Uh-huh. Okay.
they're able to reason things through much more effectively. So in this case, after seeing the chain of thought example, the LLM was able to reason, okay, Sammy wants to go where there are people. Populated areas have lots of people, so the answer must be populated areas.
That's amazing. It really does seem like we're giving them a glimpse into how we think, showing them how to connect the dots.
It is pretty remarkable.
Yeah.
But I do want to emphasize again that, these LLMs, they're not perfect. They still make mistakes. And there are certain types of reasoning that they might find more challenging than others.
So it's not like a foolproof system.
Right. But it's definitely a step in the right direction.
Okay, so we've talked about the successes. What about the challenges? I mean, what are some of the things that researchers are still grappling with when it comes to chain of thought prompting and LLMs?
Well, one of the big challenges is ensuring that the LLMs are providing reliable and accurate reasoning,
Mm.
right? We don't want them to just make things up or come up with answers that are, logically flawed.
Right, we want to be able to trust their reasoning.
Exactly. And that's an area where there's a lot of active research going on, developing mechanisms for LLMs to actually verify their own reasoning, to
Right.
kind of double check their work.
So it's like giving them a built-in fact checker.
Right. Yeah, that's a good way to put it.
Interesting. And then there's also the issue of the the sheer size of these models, right? I mean, some of these LLMs are incredibly large and computationally expensive to run.
Oh, absolutely.
Yeah.
And that limits their accessibility,
Yeah.
It makes it difficult to deploy them in real-world settings. So there's a lot of research being done to try and make these models more efficient, more compact, without sacrificing their reasoning abilities.
Okay, so it's kind of a balancing act.
Yeah, very much so.
It's amazing to think about how far this technology has come in such a short time. I mean, it feels like we're on the cusp of something truly transformative.
I agree. It's a very exciting time to be working in this field.
So what are some of the other things that are like on the horizon? What are the next steps in this research?
Well, one of the things that researchers are really interested in is exploring ways to make chain of thought prompting even more effective. Experimenting with different ways of structuring prompts, providing feedback to the LLM during the reasoning process, and even teaching LLMs to generate their own chains of thought.
Whoa, so instead of us providing the examples, they could actually come up with their own.
Exactly. That would be a huge step towards creating truly autonomous AI systems, capable of independent thought and problem solving.
That's pretty mind-blowing. But before we get too ahead of ourselves, let's maybe dive back into some more specific examples from the research paper. I think seeing how this technique is applied to different types of reasoning tasks would be really helpful.
Yeah, I agree. Let's take a look at how chain of thought prompting is being used to tackle tasks that require symbolic reasoning.
Okay, I'm ready. Let's see what these LLMs can do.
So let's dive into an example that showcases this chain of thought prompting in a common sense reasoning scenario. Researchers asked the LLM, they asked, Sammy wanted to go to where the people were. Where might he go? And they provided options like a racetrack, populated areas, a desert, an apartment, and a roadblock.
Okay, so this is testing the LLM's ability to kind of understand basics, social dynamics, and, human behavior.
Right, exactly. And as we've discussed, without any prompting, LLMs often struggle with these common sense reasoning tasks. But in this case, when they were provided with a chain of thought example, the LLM was able to deduce that populated areas was the most logical answer.
So they basically gave it an example of how to think through a similar situation step by step.
Yeah, they provided a scenario, something like, Jenny wanted to buy a new book, where might she go? Followed by the thought process. To buy a book, you need to go to a place that sells books. A bookstore sells books. So the answer is a bookstore.
Okay, so they're showing the LLM the connection between the different pieces of information.
Exactly. And then the LLM, after seeing this example, it was able to apply that same logic to the Sammy scenario, reasoning, okay, Sammy wants to go where there are people. Populated areas have a lot of people, so the answer is populated areas.
Wow. It's really impressive how they can like take that example and apply it to a totally different situation.
It is. It shows that they're not just, blindly matching patterns in text, but they're actually engaging in a more human-like reasoning process.
It's pretty mind-blowing, actually. We're essentially teaching machines to think more like us.
Yeah, it's powerful technology, and as with any powerful technology, it's important that we use it responsibly and ethically. But the potential benefits are huge. I mean, imagine a world where AI can help us solve complex problems, make informed decisions, even foster greater understanding between people.
Yeah, that's a vision worth striving for. And it seems like the research in this field is just like advancing so rapidly. What are some of the next big things on the horizon?
Well, one area of active research is um, how to make this chain of thought prompting even more effective. So researchers are experimenting with different ways of structuring those prompts, providing feedback to the LLM during the reasoning process, even teaching LLMs to generate their own chains of thought.
Whoa, hold on. So instead of like us providing the examples, they could actually come up with their own.
Exactly. And that would be a huge step towards creating truly autonomous AI systems capable of like independent thought and problem solving.
That's incredible. This is like we're on the verge of a whole new era of AI where machines can reason alongside us, helping us tackle some of the world's biggest challenges.
It's an exciting time to be alive and witnessing these advancements.
Yeah.
And as we continue to explore this frontier of AI, I think it's really important that we have these conversations about the ethical implications and make sure that we're using this technology for good.
Well said. And to our listeners, we hope this deep dive has, sparked your curiosity, maybe inspired you to learn more about this incredible field. The future of AI is full of possibilities, and it's a journey we're all on together.
So keep exploring, keep asking questions, and keep an open mind. This world of artificial intelligence is constantly evolving, and who knows what amazing breakthroughs are just around the corner.
Until next time, fellow deep divers, happy exploring!